Let's quickly talk about the general method of finding the derivative of the function. Suppose we have a function, suppose we have a function y equal to x to the n power, and we want to find where n are all real numbers. Suppose we are asked to find the derivative of this function. And please take note that the derivative of any function is the algebraic method of finding the slope of a function, because y is equal to x to the power of n. This is the function. If you should plot this on a graph, you can have a curve. You can actually have a curve. So if you want to find the slope of this curve, by right, you are supposed to find the increase in the change in y, and you divide it by a change in x, and you find the slope of this curve. But it won't work because this is a curve. Had it been it was a straight line, then you can use change in y divide by change in x. So assuming we are asked now to differentiate this function, which is the same thing as finding the slope of the curve. Now, we want to use the general method. If we are to use the first principle, we have to add the increase in x to x and the increase in y to y. But that will take us much time because x now is to a power of n. We don't know what n is. What if n is 100? Or what if n? Okay, what if n approaches infinity itself? So now, if we are to use the general method, the derivative, which is dy over dx, is equal to nx to the n minus 1. This is what we have. So this is just very easy. Only what we did here, we bring down the power n and then subtract 1 from the power. That is just it. You have the function x to the n power. First of all, bring down the power, write the function again, and subtract 1 from the power. Then you get the derivative. So what if we are having y equal to x to the power of 5? What will be dy dx? Dy dx will be equal to, following this formula here, we said bring down the power, which is 5. So you have 5. Then you write your x back and you subtract 1 from the power, which is 5 minus 1. And of course, this is going to give us 5x to the 4 power. So that is the slope of that function. Now, you can be wondering now, because I didn't say this in my previous video actually, so I'm going to say it here. You might be wondering, why are we still having our slope in terms of x? Now, you know that if you plot a graph and you find the slope of your function, change in y over change in x, you always have a real value, say 5, 6, 0 point something, all that. Now, why are we still having it in terms of x? Well, if we are given an initial condition for x, then we can substitute the initial condition and we are going to find the actual value of our slope. So since we are not given the initial condition, we only assume the function y equal to f of x. We just assume the function and then we plot the graph. But in a real graph, they will give you value of x, which you are going to use to find the coordinates before you can then plot the graph. So if we are given an initial condition, then we can go ahead and substitute to find the real slope of this function. So this is how to use the general method to find the derivative of a function. Let's take another couple of examples. Let's assume we have y equal to 4x to the second power. Now, what will be the derivative? The derivative here is, please take note, 4 is a constant and the derivative of a constant is 0. So we are not differentiating 4, which is the constant. So we always keep the constant. So we have 4, which is the constant. We don't touch the constant. Then you apply this formula here. You apply the formula. So we say bring down the power. So you have 2, and then you write the function and you subtract 1 from the power. So 4 times 2 will give us 8 x to the power of 1, and this is equal to 8x. So the derivative there is equal to 8x. That's it. Also, if you have y equal to, let's say, x squared plus 3x, you want to find the derivative of this function. So you have the y, the x equal to, apply that same formula, bring down the power, you have 2. You write your x and then you subtract 1 from the power. And this is 3. Bring down the power of x here. The power of x here is 1. So you have 1. And then you write the x back and you subtract 1 from the power. So you have 1 minus 1. So this is going to give you 2x to the 1 power plus 3x to the 0 power. So you have your slope, the y, the x equal to 2x to the 1 power is the same thing as 2x plus x to the power of 0 is 1. Don't forget, anything to the power of 0 is 1 except infinity. So you have 3. So that's the answer to that given function using the general method. So I'm going to see you in the next video for more details about differentiation, where we have rules of differentiation, we have the product rule, we have the quotient rule, we have the chain rule, and all that. So I'm going to see you in the next video. So if you enjoyed this video, please like the video and share the video to your friends who are in need of it. And if you are new to this channel, subscribe. Please subscribe.